So I think one of the most important things to note right from the start is that the Eclipse IoT ecosystem is going to have a lot of projects that work together in order to provide full-scale commercial enterprise functionality. So there's going to be stuff here where you're like, could I also use this? The answer is absolutely. So the question is, what's the right tool for the job? Every open source ecosystem has a variety of options. So Eclipse ioFog, as Benjamin said, open source fog computing. Some also call it edge computing, and some call it ambient computing, although not so many of those people. So just real quick, what I'm going to do is I'm going to talk about why you need to be at the edge, then what is Eclipse ioFog, and then we'll dive into a customer use case. So there are 7 commonly stated business reasons for being at the edge. We'll breeze through them. Latency is one of the primary ones. It takes 250 milliseconds to go to the cloud and back on average. And yet, in a lot of industrial use cases, you need latencies in the microseconds at worst. And so that's a non-starter, right? So it's a factor of several thousand times faster that we need. Bandwidth and cost go together. So obviously, if I'm going to collect 2 terabytes of data every week from a piece of machinery, I would prefer not to send that to any kind of a back end if I could do the operations on the data right there. And it's not often talked about, though, data corruption and also duplication. So speaking of those 2 terabytes, if I'm going to move them somewhere, which is a system of record? And then what happens in the transit of 2 terabytes of data over wireless or wired networks is that you have the opportunity for data corruption, and then you need retransmission and so on. Just far better to leave it where it lay. And then compliance and security go hand in hand. So we have a lot of activity now with GDPR, and we're going to see more in the near future. So are you in compliance when you move the data from a customer location into your back-end cloud in order to do operations on it? Maybe, maybe not. Far better if you can guarantee the location of the data. And then, of course, security. We'll actually talk a lot about security in this presentation. So those are the reasons, but now, why open source? So I wanted to give some insight into what companies and my customers have been saying regarding their choice to use open source for edge computing. So, and that's Eclipse IoT at the edge for the win. So community benefits. Just in general, open source stuff gets tried in a lot more environments. So you're more likely to have something that is robust than something that's only been tried for, let's say, telecommunications industry, and then you try it for logistics, and it turns out it has a lot of different problems. And it's auditable. So think, if you're going to embed some edge computing software into your product and then put it out in the world, can you guarantee what's actually running there? Do you even understand everything that's running there? How about the presence of backdoors, et cetera, right? So fully auditable. And skill sets. As we all know, when it came to big data, the fact that we had a couple of central technologies made it possible for us to leverage the skill sets across different companies. Proprietary stuff is a little bit harder for companies to adopt because they're making a big bet on that company's skill set growth. And organizational risk. So we all love startups, but what if XYZ startup goes out of business after 2 years, or even worse, they get bought by somebody who says, you need to start charging now for the things that you used to give away. This dramatically changes the engagement with all of their customers. So open source is much safer for companies to adopt, especially at the edge. And now owning the infrastructure. Think about it. You bought the compute, so you bought the hardware. You pay for the electricity to run it. You pay for the network that it runs on. At what point are you wanting to pay metered costs here? With the cloud, it makes sense, right? It's their servers, it's their electricity, it's their network. So you pay them a monthly expense, and you figure that's about fair. But you're doing all of the work. Why would you ever pay somebody to run your infrastructure on your own hardware in your own building, on your own electricity? That comes up a lot with customers. And now owning the data. Everyone would love to have your data. If for the last 80 years you have been manufacturing laminate flooring, and now you're going to use edge computing in order to manufacture laminate flooring better, would you like to give all of your operational data to some company, or would you prefer to keep it like you have for the last 80 years? This also comes up a lot. So with open source software, you might have that option. You should have that option. And there's a true ecosystem focus. There's an ecosystem focus for proprietary systems and structures, but they have this thing called a walled garden that they're aiming for, which is, this is the ecosystem we'd like you to buy from. Open source tends to actually build true ecosystems. And the last point, enterprise integration. So once the data and all of the information that you've been working with flows through your proprietary infrastructure into some backend that they charge you for, it's often very difficult to integrate it, especially in near real time, into your existing backend systems. There's a lot of middleware integrations and stuff need to take place. But with open source, often you have the ability to pipe it directly in because the open source components are one piece. Now, what on earth is this thing called Eclipse ioFog? So I figure I'm going to, it's a complete edge computing infrastructure foundation, but I figure I'm going to give you a little bit of information about what it is, and then it will make a lot more sense how customers are using it. So version 0.53 is about to come open with a GA. And this is the first version that will have all of the components available for you to install on your hardware. Up until now, there's been more and more getting added, but and people have been getting kind of some sneak previews of it. But finally, there'll be full documentation and all the components. And that means that there's no piece of this that actually needs to exist on anyone else's systems. And there will be a new iofog.org destination site, that'll be directed from Eclipse in short order. And then you can find everything already at github.com ioFog. That name may change as we roll out 0.53 being administered with the code base being administered by Eclipse. And so what's included in that? What are the components? So you have this thing called the ioFog agent, which gets installed in the hardware, and then it turns that hardware into edge compute. We're going to deep dive into that a little bit. You have the fog controller, which is your control plane and the APIs that you use to manage all the stuff. There's an IO authoring UI, which is a GUI that's used to make it easy to administer the whole thing. And there's this thing called ComSat, and this is how you enable the peer-to-peer mesh networking to run on your own infrastructure. And again, you don't want to be bouncing off of someone else's systems and servers if you need data privacy. Also, SDKs. So that's not all the languages, but those ones are used very frequently. With Go being used a lot more every month that goes by. And then some example microservices. This is all stuff you'll find at github.com/ioFog. And this is all stuff from Eclipse. So this is what the ioFog agent is. This is the piece that really kind of matters, because the rest of the stuff is things that you could probably figure out how to do. And there's some central server doing the control plane. This is what runs on the hardware. This is a 30 megabyte install. I think it might be less than that already, and we're aiming to get it lower all the time. So at the bottom layer, it's what we call an edge kernel. Hardware abstraction, resource management, some security tie-ins to hardware root of trust, and so on. Health monitoring. And right above that, fog services. So think about what made Amazon Web Services successful in the early days. It was the first time we had ever seen it, things like S3. So you create an S3 bucket, and if your team members were writing their own unstructured file storage, you would slap them on the wrist because it's been done, and it's been done really, really well. Just please use the APIs. We need the same stuff at the edge, because developers shouldn't be spending 30–40% of their time moving data from point to point. That should be part of the infrastructure. How about working with the data, which is the business value? So that's all fog services. And then above that is the whole, how do we run applications? Applications, in the case of Eclipse ioFog, are microservices, which can be either unikernels or Linux kernel containers. And that means Docker containers are already completely compatible. That's what most people use, is Docker tooling, the Docker containers on Eclipse ioFog. It can be anything. Important points here is small stuff. Let me talk to some sensors and ingest data, or let me do some analytics or some business logic at the edge. But you can also do things like machine learning. You can take Google's TensorFlow for image recognition, package it, push it out with Eclipse ioFog to some edge hardware just as it is. You don't need to compile it in any special way. You don't need to rewrite anything. And that process, I think we did TensorFlow with the whole image recognition neural net and push it down. It was about 350 megabyte container. It took about an hour to package it and push it, and that was fun. And it worked really great. And I believe these open because do whatever you want. Often, companies will take existing code that they have that's been running on some back-end server. One example is an oil and gas company took some C# code that's been running for 12 years on some Windows boxes, and they wanted to run it out at the oil pumps. They packaged the existing code. It took them an afternoon, and then they pushed it out with Eclipse ioFog. So now they have running at the edge software that they didn't have to rewrite at all. They just needed to do a little bit different DevOps on it. So why would you use it? What do you do with it? So the grand goal, make it possible to run any software. That means all types of software, not just weird plugins for the edge and not just like lambdas, but real software in any physical space on the planet, but yet have the security and the remote control that we've come to love about cloud architecture. And make building for the edge as easy as building for the cloud. Those are reasons to run it. Also, guaranteed data location and access, so full data provenance. This is really tough, because if you're collecting data from a sensor, that involves some sort of on-premise gateway and so on. And then that data usually needs to be passed to some layer in which you do some analytics, and sometimes it even needs to be passed to some cloud. How do you know where it's been? How do you know what happened on the customer's network? Up until now, for the most part, we have equated network connectivity with data access, meaning if you're on the network and the data is flowing, it might be encrypted, but you can capture the packets. And we look at connectivity as being the enabler of data access. It's my personal philosophy that that should no longer be the case. Connectivity should be a pipe through which everything flows, but the pipe should not equate to access to the pieces or the things going through it. So really cool stuff involving like the ability to use geolocation to limit data access and stuff. And now you should be able to secure the edge, or with it you can secure the edge in a scalable way. And I'm going to show you guys, and was that a hand for a question? Or okay, great. Will be time for questions at the end. What does it mean to secure the edge in a scalable way? These are the 8 requirements. This sounds like a blog post title, right? Because you always put a number in it. The 8 requirements of secure enterprise edge computing. So you have to be able to trust your hardware. Even if you choose hardware that doesn't have TPM in it and so on, you should be able to add something that allows you to identify that the hardware is the same hardware that you put out the door before it went into a factory or on a park bench or on a city bus. You need to know that the software that you're running is pure, because otherwise it could have backdoors in it and so on and so forth. And you need to know, or you need to be able to authorize what software on what hardware. Really good example is in the central office in the factory building, you are allowing microservices to run that process employee identification information because that hardware is in a secure location. But out on the factory floor, all you're picking up is the Bluetooth and RFID signals from some of the equipment around the forklift and so on. If you accidentally allow the microservice with employee ID information to run near the forklift, you have 30, 40 employees walking by who could get access to it. All they have to do is plug in a keyboard or a monitor and watch the data go by. This is not good. So what software on what hardware is very different than the cloud? Think about it. In the cloud, do you care what server in the data center your application runs on? Not if they're all roughly equivalent, right? They're abstracted. And at the edge, we really, really care. Doesn't make a lot of sense to tell an oil pump to start making coffee. So you would want to know for sure that the right software in the right place. And you're going to need to deliver secrets. I heard mentioned in the last presentation, delivery of one-time use passwords securely so that you can roll on and you don't have like stuff hanging out there that's dangerous. Exactly. At runtime, you want to be able to deliver secrets and config information, maybe some API keys. You need total control over the data flow. And then you need to automatically take action at the edge before something gets much farther, so automated quarantine. If your customer is using your product and it's built with edge compute, and you're not there to do anything about it, and they don't have connectivity to your cloud, then if there's a security breach, you might not find out until they've been completely successful in tapping into all the resources of your customer's factory. This is not so good. So in other words, security at the edge that takes place at the edge. What happens when you shut it down and you've accumulated some data, you'd like to wipe it off? You need to make sure that these things, we guarantee clear the cache, clear the data. And finally, all of this is nice as long as the software is intact. I can't prevent jailbreaking, but you should be able to detect that something has changed so that the binary signature says, we really shouldn't trust this node. Maybe we want to now disallow it from the network. So that's that quarantine. Okay, here's some principles. Architecturally, be protocol agnostic. That's because there's lots of great protocols and there will be more. Be fully distributed. If they can't own the infrastructure around it, then is it really open source? If you have to tap into someone's commercial cloud, probably gray area. Be backend agnostic. If I want to use Azure Cloud, sure. If I want to use the servers I got in a private data center, sure. Full control over data flow, we already mentioned it. Be hardware agnostic. Okay, that's not always a principle that's required. For Eclipse ioFog, it is. It's one of our guiding principles. Make development for the edge as easy as the cloud. Be OS agnostic. if you use Linux. That's where we are right now. We do have a version that runs on, a prototype version that runs on Android and one that runs on iOS actually, which I think Apple would really, really hate because we can dynamically push code in. But, and then use software to overcome hardware issues. If I can tap into something via a serial port with one more microservice, that's using software to adapt the hardware to the situation, as opposed to saying we need a gateway box that has RS-232 APIs available. And then make connectivity truly commoditized. This would be what I was mentioning before. I don't think that because you're on the network, you should be able to do anything. I think you need to be part of some kind of a network where you have the right signature matching and you've been allowed. Okay, so this company is a masked name. It's really close, though, to the company itself. We're calling it Smart Tools 4.0 GmbH, which is the 4.0 reference to Industry 4.0. And they're obviously a German company, which if you can make it work in Germany, it'll probably work everywhere else. And that is a great test ground, right? So do your deploy in Germany first. And this is an edge computing case. So what they're doing, tools that know which employees are using them. What would you do with this? If the tools have some kind of a danger factor, in the case of like an angle grinder, very dangerous if you're using it improperly, so you can improve proper safe usage, provide training to particular employees, and you can increase the workplace efficiency. Cool. Employees are a little, because are you watching me, big brother? But it's like, actually we are, and we have some recommendations for you. You could get your job done faster. Tools know on which jobs they're being used. So I would like to allocate the tool products efficiently. And for the company that's providing these tools, making these smart tools, they know it might mean that there's fewer of their tools being purchased for a particular site. And that's okay, because they'd like to sacrifice having their tools lying around doing nothing in exchange for their customers trusting them more and more with business insights. That's a bigger future for them, right? It's a digital future. They can increase throughput and, the business insights on production planning. Track the location of tools and parts. So again, production efficiency, reduce the tool inventory overhead, and support production planning. And then sense the tool usage, angles and pressure, and then what about using a blade from another vendor that's not quite compatible? So that would be important to say, you know, you're actually going to shorten the lifetime of the motor on this tool. We know because you're using this thing. You know, you can use what you want, but it's going to harm your warranty and so on. All right, so this is a pretty standard topology for the edge. We all know what the cloud is. And then each site, this tends to be the conversion from on-premise to what a lot of folks are calling the edge. It's a micro data center. It's a rack server or two and so on, maybe some network routers that have some security features and so on. And all of that stuff is being termed kind of an edge presence or edge compute. The thing is, there's a big gap between the devices and those back telco closets that exist on sites. And the devices don't exactly connect directly to there, and they definitely don't connect directly to the cloud in most cases, because devices usually are running an RTOS, sometimes just straight up firmware, and they often speak over low power wireless. So devices that speak over Wi-Fi, they often have a short battery life. And so if we're deploying things in a warehouse, you probably want them to be on the shelf for 2+ years before you need to maintain them. Even better is that they almost never need to be serviced. And so low power wireless is the way to go. Bluetooth Low Energy or LoRa, and these are some of the great technologies. Zigbee sometimes still comes up. So here's this layer right between the devices with the low power weird wireless networks and the regular LANs, the TCP/IP, Wi-Fi connectivity and so on. And this is what I like to refer to as kind of the proper edge. And it could be a regular installation of Linux, it could be embedded Linux. And this is your first opportunity to do aggregate processing. It is the one step above where things are siblings. Because it wouldn't make a lot of sense if you had a pressure sensor to say, okay, pressure sensor, you're going to do the analytics for the temperature sensor and yourself and the vibration, the accelerometer. Why would that pressure sensor, who is a sibling of the other sensors, be the one doing aggregate? So you have gateways. These gateway boxes are the first chance to do aggregate, and it's also the last chance to add context. Once you get away from the work table, in this customer use case where everyone is doing the actual work, you have lost location context, employee ID context, job number context, any of the extra information you want from that table if you go all the way into the back telco closet. And that's because Bluetooth Low Energy only goes 10 meters. With Bluetooth 5, it's 4 times as far, but still, it's not meant to go over the LAN, right? So last chance to add context. Good stuff. So they have these requirements, and these are going to be pretty heavy. Many of their customers have a requirement that the data cannot leave the building. I didn't say there's no communications to their back end, but the actual data that comes from these tools cannot leave the customer building. And that needs to add context from SAP on-premise systems. This is Germany, after all. How would you do that? So if you need to tap into the on-premise SAP system and add that context before the data flows any higher up in the hierarchy, you're going to need some kind of dynamic compute capability, or at least some kind of a plugin or script that can accept like an API key and credentials, right? Because you're not going to want to bake that into the gateway. That would make it a very dangerous gateway to have on site. So the way to do it, use an edge microservice that is capable of speaking to the SAP system and gathering the data, and then you pass it some configuration once you know that it's safely up and running. Also, the smart tools the company must install their own non-data management network. So for this company, there's really good connectivity in their customer factories. And customers are like BMW, et cetera, so big companies. And they're not allowed to use it. So they have to come with their own cellular or satellite or whatever they think is right. And this is the way that they keep in touch with all of their edge compute, not the data, but the administration of it. It turns out LTE, cellular, is the way to go. I mean, it's really cost effective for them. Analytics and business insights must be produced on site, okay? And they're just doing that by pushing the microservices right there to where the data is. And now the security model must prevent endangering employees and facilities. So let's take a minute here to talk about how the security actually works and how they're getting good installations with their customers, because there's a lot of concern around this. So at the very bottom is the hardware. And the hardware contains some root of trust capabilities. It could be a USB plug-in device, or it could be TPM built into the board. Doesn't really matter. If it's Intel, you could be grabbing the microprocessor ID, which is a unique serial number that can be read from the board itself, or for the chip itself. Starting with that, you have one signature. Next one up is BIOS firmware, and then secure boot. So you have additional signatures that are used to kind of attest that this board is running what it should run. And normally you use these things in order to say we're up and running and we're secure. But we actually take that and we combine those two signatures. So I have a compound signature, right? Which, as you know, like once you hash something, it's irreversible. So just continue hashing and the end hash will always be the same if the underlying hasn't changed. On top of that then, we have into secure boot, we have some attestation of the underlying software. So basically, Eclipse ioFog is running and whatever else you've written off is being authorized. And now, unique to Eclipse ioFog, microservices signatures. So which microservices are supposed to be running, and we guarantee the shutdown of anything else. You put all those signatures together, and then you have a check on the underlying binary. And the signature is pulled from some random selection inside the Eclipse ioFog binary that includes the key that's used to talk to your backend. So in other words, if you mess with any of the stuff that allows you to jailbreak it, we can't prevent you, but we'll know. All of that's taken together and is used to sign and say this box and the software running on it and the microservices running on it all look clean. Welcome to the mesh. And that mesh network then, which I think I had a slide, oh geez, I always sequence them like this. I have to click back through them. Slide back, almost, there we go. So in a mesh, you have a bad actor. If you take the authorization process of joining the mesh, what happens is then you're granted a session key and it rolls. So this is like your RSA key fob. And so the session key is only valid while you are an active session member. If you go offline, you're going to have to re-authenticate. So if you're going offline because somebody took the gateway box from the factory and decided to get in with their own keyboard, monitor, and mouse at home and do something, signature is going to change. You won't be allowed back on. And the key that you had is worthless. But now what happens if somebody changes it in situ? So they get in right there in the factory and they put some malware in with the USB drive. A couple of things. First, we detect that something is active on the USB drive and that scan of that hardware signature doesn't match anymore and you're kicked off. You can specify that USB devices are allowed dynamically, but that's at your risk, right? So you have to open it up versus it being open by default. Or let's say that they successfully install something, I don't know how, they slip it in. Now the signature of what's running also changes. And then that would mean that you would get kicked off the mesh. Getting kicked off means you're quarantined. We still see you, but you're not allowed to transmit any data. And the data is all transmitted through the ioFog mesh. So that means that we have true control over data flow. It's only trusted nodes that are able to pass information. We'll get down to a customer diagram here, and oh yeah, monitoring time. Okay. What other requirements they had? The security one's a good one, and then, okay, has to be do-it-yourself installable by the customer. And so that means that it has to have some kind of a token. Customer powers it on, it's good to go. And that's pretty tricky at scale, because you need to manufacture a bunch of products, some smart tool products that have something in them that is safe enough that you can leave it on the shelf and maybe sell it to different customers, but trustworthy enough that once it comes online, you can say, yes, you're ready to fire up and join this customer mesh. So how do you do that? And what it is it's a starter token that says, I know where to point, and you will then, from the other side, validate me and say, you give me a chance to authenticate myself within this Edge mesh. And now Edge microservices must be commercializable. So if this company, Smart Tools 4.0 GmbH, if they can't charge for the microservices as they go, then their customer actually has a problem with them, because they're paying for ongoing services and they need to be able to monetize. And if the customer is running it and is kind of like licensed software, bought it, done, now you go ahead and copy it as many times as you want, then Smart Tool is not going to have an incentive to give subscription software and so on. So it's not that ioFog, Eclipse ioFog, has commercial microservices. It's that you have the hooks that you can create commercializable microservices. So that's pretty important. Remote management at scale and diverse hardware options for edge compute. You want to buy the best board to put in your tool. These are requirements. And then provide APIs for other vendors. Really hard thing to do if you have some kind of like a Lambda that you're running at the edge, because there's a limit to what those can do. They can process data in stream, but how do you run like a web server that has an API that allows like other tools on the network to drop data in? That's pretty cool. You can use a Edge microservice for that. So, and then management of system across customers at scale. So you don't want to have, different installation for each customer. You want the management control plane to be able to handle everybody that you do business with. So I'm happy to distribute this deck too, by the way. I see some pictures going up, and it's like there's a lot of text there, so I'm happy to give it out. So this is actually a very specific use case of the customer in which they are even providing an LTE network at the customer site for some, it's like a large scale, it's one of these, it's factory facilities where they have a lot of outdoor operations as well. So it's interesting, LoRaWAN, really good low power network to bring the devices into the gateway where ioFog is running and the microservices are running. Some are just gateways, even LoRaWAN to the drone with a little add-on card. Vehicles, tractor's probably not the right vehicle, more like front loader and stuff. And how about cameras and other monitoring equipment around? All of these things are doing the low power network here, microservices on each, so it's the same software, it's the same Eclipse ioFog, and then using LTE on the private network can do some processing right there also on the entire site location. Then you've got a backhaul, and if you want to get the data into some cloud, you can do it with another instance of ioFog. This means point to point, or you can just do the management in the cloud. And so this is what one customer site looks like. Every customer with an entire factory that's becoming advanced and becoming IoT enabled, they're going to have a lot of differences that are customized. But when you use the same software in every piece of it, at least you're standardizing the management, you're standardizing the way you would write software, right? So I'm not going to lie and say every factory is just a sweep of the hand solution once you get it right. It's not going to be the case. But at least you're using the same tools to build it out and build it out. I think that might be all I've got, and therefore some time for questions. Did I nail it on time, or are we short on time for questions? Okay.
Questions for Kilton? Questions?
So just one question. What do you do for provisioning?
Yeah. So are you talking about provisioning the devices, or are you talking about provisioning the edge
management
compute?
and operation of your application. So do you have dependency? Yeah, because you could decide, and this runs there, this runs there, or you could just provide requirements. Yeah, so constraints.
Yes. So if I understand what you're asking, let me rephrase it, and you tell me if it's right. Something like, I need to provision an edge compute board that has Bluetooth, smart, and also over 2 gigs of RAM so that I can see that it's available for the following type of processing. Is that the kind of provisioning or no? Okay, all right. Tell me a little bit more what you mean by.
So let's take as an example your customer.
Uh-huh.
Okay, so you have your infrastructure, but then on the infrastructure, hardware plus software, so where as far as your agent is running, then it wants to deploy some microservices.
Okay. Mm-hmm.
One of his applications will be an arbitrary graph of microservices. So do you have anything that supports that? Because you didn't cover, so I was just wondering if it's not part of the platform yet, or if it's not.
Gotcha.
You didn't have enough time. Yeah.
So to rephrase, and you tell me now this time if I got it right, something that gives you insight into the infrastructure itself, right? So some orchestration capabilities and some information around what's being deployed where. Is that a closer? Yeah. I mentioned the component called Fog Controller that's out there. That has a REST API for you to programmatically control, or you can use the UI called ioAuthering to do it with drag and drop. And the drag and drop, to be honest, is not ready for big scale. You would probably want to write into Ansible or Chef or Puppet, something if you have a DevOps deploy procedure. A lot of different stuff you can do with build tools to say, open a compute node, right? And when it joins the mesh, push these microservices, and you can do it through the REST API. Yep. Mm-hmm. It's getting better all the time, of course. Managing at scale of 10,000 is different than 100,000, so we're learning still, to be honest. But yeah, cool. Yes.
Thank you. You pointed out that what hardware the software is running on is a key link. And it seems also that after provisioning, the fact that the hardware is relatively fixed is also important, because that's location and stuff, right? Because that gives you the... after that, I have a follow-on question.
Okay, it's only important that the hardware be in a fixed location if you're not going to feed... So there's an API in the Eclipse ioFog agent for feeding in the geocoordinates. So every microservice has the opportunity, when you authorize it through the control plane, has the opportunity to feed in the geocoordinates. So, and if you use a microservice to talk to a GPS module, then you can get dynamic. But if you're going to put it on a warehouse shelf, you're not going to pay for a GPS module. You would probably want the microservice that you authorize to set the coordinates to just come with some configured coordinates, and then you're done. So in that case, they will be fixed, but it's really good for dynamic stuff as well.
Okay, thank you. And also comparing it to the Kura that was talked earlier, it seems now the Kura was so that the equivalent to Kura would be the ioFog agent, right? Kind of the
I think that's a really good comparison as far as like what would be on a gateway. Yeah, that's a pretty close assessment.
And I know Kura, he said, was based on at least at that level on the TCP because it's on MQTT. What is your kind of equivalent of that?
So the protocol that's used in Eclipse ioFog is proprietary is not the right word, but it is unique to Eclipse ioFog, which is how the information gets passed around the mesh from one Eclipse ioFog node to another. It's equivalent to like HTTP in that you can pass any bytes and put a labeled header on it. It can carry MQTT, it can carry CoAP, it can carry just about anything you want. It will be heavier than Kura. And so there's definitely a spot in which Kura is the right solution. There's a spot in which Eclipse ioFog might be the right solution. If you're doing streaming video, Eclipse ioFog might be more friendly for that because MQTT, of course, has a byte length limit to each packet. Yeah.
I do have a question about the device provisioning. I mean, how to connect the device. Is there any kind of a service which has been existing in the infrastructure? For example, so if you take the Azure, we do have the device provisioning service, which it's an infrastructure which helps us to connect the device to the Wi-Fi.
Yeah, okay, gotcha.
Yeah.
I gotcha. You're talking about like the end device itself, right? Like a sensor and so on.
Yes.
So I'm going to give you a cool example of what you can do with ioFog that's really difficult to do with other stuff. So imagine you have a Bluetooth low energy wearable for healthcare space. And this is going to take blood pressure, monitor it automatically, and transmit it to basically anything that is authorized to pick it up. Problem is, if it has enough capability that it is dealing with Wi-Fi and so on, the battery life's not so good. And then for security reasons, you'd really prefer it to just be Bluetooth low energy only and so on. How do you associate that blood pressure monitor with a particular patient? So the provisioning process in this case is not just turning it on and getting it on the network, but who does it belong to right now? And you don't want to be adding that context in any other way because that means more places that have like a patient ID. So you'd like it to be something that's right there. The best thing that you can do is use some dynamic code at the edge, something, so you could even use a Raspberry Pi for this. Something that has Bluetooth and also compute capabilities to run ioFog can run a microservice that you deploy to the patient room, and you could give, say, the MAC address of the wearable. And that MAC address gets tied in, but it's only on the secure ioFog mesh where you're talking to the Epic patient record system, associating the MAC and transmitting data. So in other words, after the dumb thing gets into the smart thing, then we add the sensitive information. And provisioning now, turn it on, wash it, give it to the person. And there you go. So in a lot of ways, provisioning either involves embedding sensitive information ahead of time. I'm going to bash on AWS for a minute. AWS IoT requires you to embed a private key in a device so that it can talk to the cloud. This is the worst thing in the world because it's called unattended trust. You get a hold of that device, you might as well have an open gateway into the backend because it trusts it implicitly, right? It's a private key. Don't do that. Don't make your devices need to have like flashed information into them because also how would you manufacture a bunch of them? It becomes a really complex process, right? You'd like them to just be pretty dumb and then just use something like a MAC address or something to be the starter.